Hello everyone, I hope you are doing well. So in this video we are going to discuss the solution for problem C of Codeforces around 815, which was written for division 2. So this problem states that we have been given a two-dimensional array with either 0 or 1 in it at every index or at every place, and we have to replace all the ones by zeros. So the steps to do it are as follows. For example, if we have something like this, right? So we can select an L-shaped figure from it such that there is at least one present in it, at least one. Like there is the count of one is here is one, and it can also be 1 1 0 1, and then we can select an L-shaped figure from it. So we have to select these L-shaped figures in such a way that the number of moves to like make all the places equal to 0 are maximized. So we have to make it all 0 in the maximum number of moves. This is our given task. So first of all, like let us list all the shapes that we can form. Like these are the shapes that we can form from a 2 by 2 grid, right? In a 2 by 2 grid, I can either write it as this, or I can write it as this, or I can write it as this, right? So these are the shapes that I can form in a 2 by 2 grid of an L shaped, right? There's one very important observation that you will notice, that if all of them are 1, right? So in this particular case, no matter what shape I select, the number of steps will be the same. So for example, if I select this shape, then it will be counted as one step, and they will all become 0, right? Whichever shape we select, all the elements present at that place will become 0, and after it has become 0, now we are left with only 1. No matter which shape we select, we can only increase the number of moves by 1. So if in a square or in a grid of 2 by 2, all of them are 1, we can create an answer of 2, right? Now what happens if 3 of them are 1? Now let it be like this. In this particular case, I can select this shape first, and it will be 1, and the remaining grid will be like this. Then I can select this. So the final answer will be 1 plus 1, that is equal to 2. So if there are 4 ones present in a 2 by 2 grid, the answer will be 1. If there are 3 ones present, the answer will be 2. If there are 3 ones present in the grid, the answer will be 2. If there are only two ones present in the grid, then the answer will be. So in this particular case, I can take this L shape first, right? So I can turn them all 0, and then I can take this L shape. So if the number of ones present in an L 2 by 2 grid are 2, the answer will be still 2. In the case of 1, if there is one present in a 2 by 2 grid, then the answer can be obviously 1 after taking the shape, right? And if there is 0, then we cannot take any of them. So we have observed that in a 2 cross 2 grid, the number of steps required, the maximum number of steps that we can take to convert them all to 0 is minimum of count comma 2, where count is the number of ones currently present in a 2 by 2 grid, right? So there is one more thing that you'll observe. If there are two zeros connected like this, so I can always take this structure and make it an L. If there are two zeros connected like this, then I can take this structure and make it an L. So even if there are 3 ones present somewhere, and if there is a 0 and it is connected to one more 0, at least one more 0 in any direction. So for example, if I am at a point is if I am starting from the 0, 0th point, what I'll do is I'll fetch in these directions. I'll fetch down, I'll fetch right, I'll fetch bottom right, down right. And if I am and if I am traversing it like this, I am traversing it from 0 to n, and 0 to m. So I'll be traversing it from 0 comma 0 to the right side and 0 comma 0 to the downside. So at any points, the only points I need to check at any point, if I'm here, I can check down, I can check down left, I can check down right, and I can check finally right. So these are the points I need to check. I don't have to check the left part because I would have already covered it. I don't have to check the top part because I would have already covered it, and similarly for the top left. So these are the 4 points I need to check, that if the current element is 0 and there is one more 0 in either of these 4 directions, then I can definitely make it an L and I can make it 1. Like this would be one operation and we'll be left with 0, 0, we'll be left with 1, 1, 0, 0. And in this, and for this grid, the answer will be 2. Right? So this way we can make it a total of 3 steps. Right? And now if we do this, this will start a chain reaction for all the other items in the grid. For example, if this is 0, 0, 0, 0 and here is 1, 1, 1, 1. Right? Now we can again take this particular grid, and for this grid the answer will be 2. So if we find at least one position where the current element is 0 and either of these 4 directions have a 0 in it, right, in this particular case the answer will be count. Right? And if we do not have a 0 at all in the grid, like there is a grid like 1, 1, 1, 1. So for every case, what will happen with, as you can see, we are wasting 2 ones, right? So the final answer in this case would be n into m minus 2. Right? Why? Because even if it is like this, even if it is a 3 into 3 grid, to solve this particular grid, we have to waste two amount of ones. We have to sacrifice them, because if you can see, the answer would be always, the number of steps will be minimum of 4 comma 2. Right? So if we take any of the grid, we have to take all the 4 and we have to convert it into 0. The total steps would be 2. After this has been converted to 0, we have at least one amount of 0 in the grid and it will start a chain reaction, and all the other ones can be utilized to their fullest. Right? We can form a L for every one of these ones, but for the first grid that we break, we have to like make this particular sacrifice to let go of two amount of ones. Right? And if there is a case like 1, 1, 0, 1, 1, 1, 1, 1, 1, like this. So in this particular case, again, I have found one 0, but if I check in these 4 directions like this, this, and this, there is no 0 present here. Right? So again, I will have to I can take this grid, but I'll have to sacrifice one amount of ones. So for this particular grid, the answer would be 2. So in the final answer, the answer would be count minus 1. Why? Because in this first grid, I have to sacrifice one amount of 1. Right? So there will be a total of 3 cases when there are no zeros present and the count of ones is equal to n into m. So this is the very first case, and in this particular case the answer would be count minus 2. This is the case 1, right? The second case would be when there is a 0 present, but for any of the zeros, like for every 0 we check in these 4 directions and there is no other zeros present. So that means we cannot form two zeros together. Right? So in this case, we'll have to sacrifice one of those ones. So the final answer would be count minus 1. And the last case would be when we have found at least one 0 and at least one of those zeros has another 0 in one of those 4 directions. So in this case, we don't have to sacrifice any of those ones and the final answer would be count. So this is the whole idea behind this question. Now let us quickly go through the code. So I have taken 2 integers n and m, and I have taken input in a board or in an array, right? So I can take two variables. The first variable is count, which stores the number of ones, and the second variable is extra, which stores whether there is at least one amount of zeros that is present in a group of two, right? So if the current element is equal to 1, I can just increment count and continue. If the current element is 0, then I can check in those four directions. So I'll show you what are this dx and dy arrays. So this is the dx and dy array. So what it does is, like, if I add this to x and I add this to y, I'll get my position shifted upwards. If I add this to x, I'll add this to y, I'll have my position shift downwards, and similarly for all the positions I have this, right? So I need to check at D, I need to check down, I need to check at right, I need to check at down right and down left and down right. So I'll use index 1, 3, 6 and 7. So what I did was, I pushed these four values into the vector, and after traversing through the vectors, I visit each of those index. I set di as I plus dx of z and dj as j plus dy of z, and I check if this is a valid position, that di and dj is valid. In the valid function, I just check if they are between 0 to n minus 1. If they are within these values, I'll return true, otherwise I'll return false. So if this is valid and board of di and dj is equal to 0, right, I have found the second 0, so I just mark the extra variable as 1 or true, right? At the end, if count is equals to n into m, that means there are no zeros present in the array, so I will print count minus 2. Else if I have a group of two zeros together, I'll print the answer count, otherwise I'll print count minus 1. So this is how we could have solved the third question. I hope you guys were able to understand this. Till the next video talks, keep coding, stay safe, bye bye.